Welcome again. In the previous lessons, we have understood the basics of research methodology. We discussed in detail the aims and objectives of research and research designs. Further, we explored the importance of research problem, its selection, and its components. Then we studied data collection process and the related topics like primary and secondary sources and techniques of data collection. Now, let's move a step ahead. In research methodology, when we are in the process of data collection, then we should keep in mind that our objective is on exploration of sample analysis and not on exploring directly the population. As a result, we should concentrate on the effectiveness of sample design and efficient sampling techniques. So, in this lesson, we will cover the following topics: sample design, sampling design step, criteria for selecting a sampling procedure, characteristics of a good sample design, different types of sample designs, non-probability sampling and its types, probability sampling, probability sampling types, simple method of selecting a random sample, probability sampling types, complex random sampling designs, and complex random sampling designs. So, starting with the sample design.
Sample design is a definite plan for obtaining a sample from a given population. Sample constitutes a certain portion of the population or universe. Sampling design refers to the technique or the procedure the researcher adopts for selecting items for the sample from the population or the universe. A sample design helps to decide the number of items to be included in the sample, that is, the size of the sample. The sample design should be determined prior to data collection.
Sample design basically focuses on two aspects: A. Sampling technique, B. Sample size. Basically, when we are extracting the sample from the population, we necessarily have to look for the apt way of the sample extraction depending on research objective, as on the basis of sample design our conclusion depends. So, sampling design is a technique or the procedure which the researcher adopts for selecting items for the sample from the population or universe. It definitely depends on the research objective. For example, if we ought to do some research on specific medicine, then we cannot go with random sampling. We may take up purposive sampling in that case. Sample size is another important concern, as we need to make a trade off between cost time and accuracy with respect to nearness to population attributes of the research problem under consideration. So, what are the steps for having effective sampling design?
The four major steps for effective sampling design are type of universe, sampling unit, source list, and size of sample. Type of universe is basically developing the sample design wherein you are defining the number of cases which is technically known as universe. The decision to the sampling unit must be made prior to selecting a sample. Source list is also known as sampling frame in designing sample. Then size of sample refers to the number of items to be chosen from the universe to form a sample.
The very first step is to have clarity on general attributes of a population or the universe. This can be with respect to whether the population is normally distributed or not. It can be also with respect to the size of population. Now, a point worth mentioning over here is we make use of capital N to denote the population size. We may have n as a finite number or an infinite quantity. Another worth mentioning point over here is that we may approximate a very large, uncountable number as infinite number in regard to the population size. Now, the second step is to know about the sampling unit. Sampling unit may be a geographical area like a state, district, village, etc. Or it can be a social unit like a family, religious community, school, etc. It can be an individual also. This sampling unit is basically dependent on the research problem. That is, it varies from research to research. For example, if we need to analyze the COVID spread in a country, then we may take district as a sampling unit. Now from sampling unit, we move on to third step, which is basically the sampling frame or source list. This refers to the source from where we are taking the population units. It can be telephone directory, it can be website, or it can be some source lists. Theoretically, the target population and the frame are the same, but in reality, there is a difference between target population and the frame. We may have frames that have over registration, or we may have frames that have under registration. Frames that have over-registration contain the target population units plus some additional units, whereas frames that have under-registration contain fewer units than the target population. For example, consider the case of telephone directory. In this, we may have certain families that do not have landline telephones. So, this case may be the frame that have under registration. However, in reality, a business researcher's goal is to minimize the difference between the frame and the target population. He should be very careful that the frame and the targeted population do not deviate much. Then the last step in effective sampling design is the size of sample. Size of sample is the most important step in the sampling design, where we denote capital N as the population size. There we denote small n as the size of sample. The size of sample must be optimum. An optimum sample size may be defined as the one that satisfies the requirements of representativeness, flexibility, efficiency, and reliability. While deciding the size of sample, a researcher should determine the desired precision and the acceptable confidence level for the estimate. The size of the population should be considered as it also limits the sample size. For example, if we have a finite population size of capital N and a sample is big enough, then we need to have a finite population correction factor in order to get proper results. Also, the budgetary constraints and sampling procedure plays a vital role in deciding the size of the sample. So once we are aware of the sampling design steps, then we should also keep in mind that there are certain criterias for selecting an appropriate sampling procedure. Definitely, we are putting cost in collecting the data, and it may happen that our entire cost gets wasted if we do not focus on two important points. First, our sampling should be performed under controlled systematic bias, and second, that we should have a minimum sampling error. Now, what is systematic bias and what is sampling error? Let's understand. Systematic bias basically arises because of the errors in the sampling procedure. It can be because of inappropriate sampling frame, defective measuring device, non-respondence, and natural bias in the reporting of data. For example, we wish to analyze the weights of students, and for this, we make them stand on a weighing machine. But suppose that weighing machine is not set at 0. Then our entire sampling procedure is having a systematic bias because the weights are actually shifted towards the right of the 0. Such an error is called as systematic bias. Definitely, as we can decode from the example, this error cannot be eliminated by increasing the sample size. We should be careful enough that our sampling procedure is free from such types of systematic bias. The second error is basically concerned with the random variations in the sample estimates around the true population parameters. For example, suppose mu is the population mean and x bar is the sample mean. Then the difference between the population mean and the sample mean is called as sampling error. So this error definitely can be decreased with the increase in the size of the sample. Another measure of decreasing the sampling error is to make the population homogeneous. So, in nutshell, the characteristics of good sample designs are: the sample design should yield a true representative sample. In this, consider an example that we want to analyze the usage of social media apps. For this, if we focus on old aged people, then we may land up with wrong results. Why? Because our sample is not a true representative of the population, considering the fact that youths are prospect customers of using social media apps on large scale basis. Then definitely the sample design should be such that it results in small sampling error. The sample design should be viable in context of budgetary constraints of the research study. The sample design should be such that the systematic bias should be controlled, and the sample must be such that the results of the sample study should be applicable in general to the universe at a reasonable level of confidence. Till this point of the lesson, we have understood the utility and characteristics of a good sample design. Let's now find out what are the ways by which we can design our sample. So, there are basically two main types of sampling, namely non probability sampling, which is also called as non random sampling, and probability sampling, popularly known as random sampling. As per the names, there is statistical support in random sampling, whereas non-random sampling do not take into account the concept of chance factors. Let's further elaborate on the two sampling techniques and their different element selection rules. Non-probability sampling is also known as deliberate sampling, judgment sampling, and purposive sampling.
Non probability sampling is the sampling procedure that does not afford any basis for estimating the probability that each item in the population would have an equal chance of being included in the sample.
Basically, in non random sampling, the items are deliberately chosen by the researcher as per his or her choice, depending on the availability of the sample units and the judgment of the researcher. In non random sampling, the perspective is not in relation to the statistical methods, rather, it's on the judgment of the researcher. With this, let us take up the different non probability sampling types. The very first is convenience sampling. In convenience sampling, elements for the samples are selected for the convenience of the researcher. So, it's a non probability sampling technique where researchers select sample just because they are easy to recruit. An example to convenience sampling can be like this. Suppose a researcher wants to conduct door-to-door survey. Now, in convenience sampling, the researcher may take up the houses where people are at home, or houses that do not have dogs, and houses that are not at high floor. Another non-probability sampling type is quota sampling technique.
Under quota sampling, the researcher simply assume quotas to be filled from different strata with certain restrictions imposed on how they should be selected. This type of sampling is very convenient and is relatively less expensive.
In quota sampling technique, the population is divided into different categories. These categories are called as quotas. So we can have quota of gender, age, or income groups. In quota sampling, one should keep in mind that the samples should be in the proportion of the population. For example, if we have in a city that the male and female ratio is 60 is to 40, then the sample chosen should be nearly of the same ratio. Moving on to the next non-probability sampling type, we have the judgment sampling.
In the judgmental sampling method, researchers select the sample on the basis of purely researchers' knowledge and credibility. Judgmental or purposive sampling is not a scientific method of sampling, and the downside of this sampling technique is that the preconceived notions of a researcher can influence the results.
Judgment sampling or the purposive sampling occurs when elements selected for the samples are chosen by the judgment of the researchers. Researchers often believe that they can obtain a representative sample by using sound judgment, which will result in saving time and money. So, researchers choose only those people who they deem fit to participate in the research study. Consider a scenario where a panel needs to decide to understand what are the factors which can lead a person to select ethical hacking as a profession. In such case, the researcher who understands what ethical hacking is will be able to decide who should form the sample to learn about it as a profession. So, this is the case of the purposive or the judgment sampling. Moving on to the last non probability sampling type, we have the snowball sampling. Snowball sampling is a technique in which sample objects are selected on the basis of referral from other survey respondents. For example, suppose a person from a particular car company is on the way of gathering information on who all are interested in buying the company car. In that case, a researcher may call a person who is currently using the brand in order to seek a referral from him of the prospect customers. So, in this, once the researchers find suitable objects, he or she may then ask them for assistance to seek similar objects to form a considerably good sample size.
So, snowball sampling helps researchers find a sample when they are difficult to locate. Researchers use this technique when the sample size is small and not easily available. As said, this sampling system works like the referral program.
These were the different types of non probability sampling techniques. So, moving on to next type of sampling technique, which is probability sampling. Probability sampling is also known as choice sampling or random sampling. Random sampling is used widely for sampling purposes. In this, the subjective perspective of non random sampling is taken over by probabilistic selection of elements. Therefore, in this, only chance would determine whether an item or the other would be included in the sample or not. Random sampling satisfies the law of statistical regularity, according to which, if on an average the sample chosen is random, then it would have the same composition and the characteristics of the universe. For example, Suppose we randomly select a drop from an ocean. Then we expect that the drop have the same composition and the characteristics as of that of the universe. Now moving on to probability sampling types. The very first and the simplest method of selecting a probability sampling type is simple random sampling. A simple random sampling can be compared to that of a fair lottery system. Suppose we have a box containing lot of numbers. Then, if we randomly select a number and keep it out as a sample, then this is called as simple random sampling. Usually, the population that we consider is having a very large size or a size which approaches to infinity. So that means when we are selecting a sample from that population, then each and every unit has equal chances of getting selected. However, with finite population where the sampling is done without replacement, there simple random sampling ensures that in successive drawings, each of the remaining elements of the population has an equal chance of being chosen, and hence the simple random sampling method results in the same probability for each possible sample.
So, in nutshell, it is said that random sample is a process of selecting a sample that involves writing the name of each element of a finite population on a slip of paper and then putting them into a box or a bag. Then they have to be thoroughly mixed, and then the required number of slips for the sample can be picked one after another without replacement. While doing this, it has to be ensured that in successive drawings, each of the remaining elements of the population has an equal chance of being chosen.
Moving on to probability sampling types that involves complex random sampling designs. This can be taken as a hybrid structure of probabilistic and non-probabilistic sampling techniques. So, a complex random sampling design can be a combination of non-probability and probability sampling procedures, or it can be a combination of probabilistic and probabilistic sampling procedures, or it can be combination of non-probabilistic and non-probabilistic sampling procedures. The very first in complex random sampling designs is systematic sampling. In systematic sampling, the randomness is only with respect to the first element of the sample. Then, after regular steps, a sample is selected and hence the name is systematic sampling. For example, if a 10% sample is required out of 100 items, then the first item would be selected randomly from the first 10 of the items, and thereafter every 10th item will form the component of systematic sampling. Such sort of sampling can be used in cases where we are aware that after every regular interval there is a change in the classes. Suppose we have students belonging to a particular course and we know that a section comprises of 25 students. Then we can randomly select a student from first class. Then after every 25th count, we can have a student belonging to different class group. So this kind of sampling is the systematic sampling. Now the next is the stratified sampling. In stratified sampling, we divide the entire population into homogeneous groups, which are called as stratas. This can be compared with the quota sampling of non-probabilistic sampling type. The difference between quota sampling and stratified sampling is that in stratified sampling we adopt statistical method. However, in quota sampling we were making use of subjective perspective. After dividing the population into homogeneous groups, we can select the elements randomly from each stratas.
So, to conclude stratified sampling, we have that when a population from which a sample is to be selected does not compromise a homogeneous group, stratified sampling technique is generally employed for obtaining a representative sample. Under stratified sampling, the population is divided into many subpopulations in such a manner that they are individually more homogeneous than the rest of the total population. Then items are selected from each stratum to form a sample. As each stratum is more homogeneous than the remaining total population, so the researcher is able to obtain a more precise estimate for each stratum.
A wider version of stratified sampling is cluster sampling. In cluster sampling, the entire area is divided into smaller, non overlapping areas and then randomly selecting a number of such smaller areas. Basically, the difference between stratified sampling and cluster sampling is like this. In stratified sampling, we are dividing the population into homogeneous groups. That is, within a strata. Say we divided the entire population into different age groups. Then, in a particular age group, which is strata, we can expect a certain homogeneity. However, between the different age groups, that is, between the different stratas, there is heterogeneity. But in cluster sampling, the clusters are heterogeneous. However, we can expect similarity between the different clusters. Area sampling is the extended version of the cluster sampling, wherein the clusters are in the form of some geographic subdivisions. They can be used in analyzing the different districts. Area sampling can also be used in Google Maps. Then comes the multi-state sampling. So multi-state sampling is basically wherein we are adopting sampling at different stages. For example, we need to analyze the COVID situation in a country. Then at first stage, we randomly select a state. Then from that state, we randomly select districts. So here we are moving with two-stage sampling design. Same way, we can extend such type of designing into multiple stages. Coming on to the last sampling technique, we have sampling with probability proportional to size. This we have discussed while taking up quota sampling. We can also take this in cluster or stratified sampling. So it is the case when units does not have exactly or approximately the same number of elements. Then it is better for the researcher to adopt a random selection process where the probability of inclusion of each cluster in the sample tends to be proportional to the size of the cluster. For example, we need to compare two states like that of Maharashtra and Kerala. Then Maharashtra is bigger in size as compared to Kerala. Accordingly, we should extract samples as per the proportions of the clusters. These were the different sampling techniques that can be adopted by the researchers depending on their research problem. Before winding up, let's have a quick view on how to perform the different sampling techniques in Excel. So we'll be taking up quickly simple sampling, systematic sampling, stratified sampling and cluster sampling. We are considering a population wherein we are taking the adjusted closing price of a stock named Enphase Energy Limited. We wish to extract 50 units in a simple random manner. Then, using Excel ran between number, we can generate a number randomly between 1 to 2013. And once this number is selected, then using VLOOKUP function, we can take up the necessary information corresponding to this random number generated. For example, here the random number generated is 2 and corresponding to 2, the date is 22nd August 2012 and the adjusted closing price is 5. These 50 units represents the simple random sample. Moving on to systematic sampling. Systematic sampling, if you remember, takes into account a constant step size. We need to extract a sample size of 50, and hence we determine a step size which is obtained as a ratio of population size to the sample size. And once that is generated, which is approximately 40 over here, so we run a simple ran between function between 1 to 40. Now this is the first element that involves the random component. The next components will be with the step size of 40. That is, from element 2 we will have the sample units in a systematic manner. Moving on to stratified sampling. In this we are first converting our data into different stratas. So these are the slabs which are basically indicating the different stratas of the adjusted closing prices. Now once these stratas are made, then we are randomly selecting the units from each slab. So such kind of sampling is called as stratified sampling. Moving on to the cluster sampling or multi-stage sampling. In this, we have taken the data corresponding to district-wise crime under various sections of IPC. Now, in this, we have run multi-stage cluster sampling or multi-stage area sampling, wherein first we are randomly selecting the state, and then after randomly selecting the state, we are randomly selecting districts in each state, and then ultimately we are finding the crime figures corresponding to that randomly selected district code. So this is how we perform cluster sampling in Excel. So with this quick Excel aid, we come up to the end of lesson 5. In this lesson, we discussed in detail the sample designs and different types of probabilistic and non-probabilistic sampling techniques. A researcher should necessarily mention the type of sampling technique which he or she is adopting in the research, giving the justification with respect to the research aim. Definitely, the researcher should keep in mind that while extracting a good sample, he or she should be very much careful with respect to the systematic bias and the sampling error. So, with this, we conclude lesson 5 and we wish you all a happy learning.